this is a beautiful question. We've been expected to integrate x raised to the power of x times x raised to the power of 2x positive 1 times 1 positive ln x over x raised to the power of 4x positive 1, and that has to be multiplied with the differential operator dx. Now, the very first glance at this question would really take most students by surprise. In fact, even people who are doing calculus or who have completed calculus, because this needs a lot of practice and understanding, because this involves 2-3 types within it. So foremost, we would like to convert this by integration by substitution. So what I will do is I'm going to make this substitution. So let x raised to the power of x be equal to t. When I differentiate this, I get x raised to the power of x times 1 positive ln x times dx is equal to dt. I've already shown you how to differentiate x raised to the power of x in the previous classes. So this is what we have got. Now clearly we can see that x raised to the power of x times 1 positive ln x dx is actually dt. So let us replace that. So this is equal to, now x raised to the power of 2x, now that is going to be rewritten as, this is what we have got here, right? I can always write this as x raised to the power of x raised to the power of 2. And x raised to the power of 4x, I can always write it as x raised to the power of x raised to the power of 4. So this is actually for your understanding, so that you can keep track of the substitution. So I'm going to first rewrite this as x raised to the power of x raised to the power of 2 positive 1 times, I'm going to club this, x raised to the power of x times 1 positive ln x times dx divided by x raised to the power of x raised to the power of 4 positive 1. So upon substitution, this is going to be x raised to the power of x is t, so this is t squared positive 1, x raised to the power of x times 1 positive ln x times dx, this is going to be dt, divided by x raised to the power of x, this is going to be t raised to the power of 4 positive 1. Now this is the type which I have just mentioned to you in the previous problem. So what we need to do is we need to take t squared out. So if we were to take t squared out, this is going to be 1 positive 1 over t squared times dt divided by, I'm taking t squared out, so this is going to be t squared positive 1 over t squared. So clearly the t squared that you see here can be cancelled. Now I've got a quantity in the numerator, which is 1 positive 1 over t squared times dt divided by denominator t squared positive 1 over t squared. Now in the cases which I've studied, if you were to have a numerator which features 1 positive 1 over t squared, then you will have to rewrite the denominator using t negative 1 over t, right? That's exactly what we are going to do. So this is equal to integral 1 positive 1 over t squared times dt divided by t negative 1 over t raised to the power of 2. Now if you were to expand this, this will give you t squared positive 1 over t raised to the power of 2. So 2 terms are there. Now it will also give us negative 2, right? Because of 2ab, that's negative 2ab. So I need to get rid of the 2. So that is possible only when I add positive 2 here, right? So fair enough. So now what I'm going to do, I'm going to make the substitution. I'm going to state here, let t negative 1 over t be equal to sum p. So that would mean I can differentiate the left hand side, which would give me negative of negative, that's going to be positive 1 over t squared times dt is equal to dp. So clearly in place of 1 positive 1 over t squared times dt, I can replace dp. So this is equal to integral dp divided by, in place of t negative 1 over t, that's going to be p raised to the power of 2 positive 2. I'm going to rewrite this as integral dp over p squared positive root of 2 raised to the power of 2. Now we know formula. So what is the formula we know? We know that integral dx over x squared positive a squared is equal to 1 over a tan inverse of x over a positive c. So using the formula, this is going to be 1 over a, that's going to be root 2, tan inverse of x over a. Fair enough, right? But my p is actually t negative 1 over t, right? That has to be divided by root of 2. Okay, so that's fine, but my t is actually x raised to the power of x. You see that? So that has to also be reverted. So this is equal to 1 over root 2 tan inverse of x raised to the power of x negative 1 over x raised to the power of x divided by root of 2, positive arbitrary constancy. So this is a good place for us to draw the red line, and this is a beautiful question. So I would suggest that you practice yourself, and perfect practice makes great benefits. So students, having mentioned that, we will move on to the next question.